I'm very happy to participate in the Eurasian Actuarial Congress for the second time. So this time I will talk about new ways to link contribution to benefits in pay-as-you-go retirement systems, with using the Algerian case as an example. So usually the pension benefits in pay-as-you-go system are defined based on the number of years of contribution, and for which we apply an annuitization rate for each year of contribution. So that allow us to obtain the replacement rate that we apply to the final wage, and we obtain the first pension benefit. So I was looking in the literature to find a source from this classical way to define pension benefits in function of the final wage and number of years of contribution and so on. So I figured out that there is no clear way to how this relationship is defined. So in some countries is 2.5% for each year of contribution, and in others is 2% by the number of contribution, and so on. And policymakers and reform designers handle this rate in function of the future evolution of the financial sustainability of the systems. So in our opinion, this might lead to some inequalities regarding if we take the pension contract as from an investment point of view. So here inequality, we consider retirement contracts as an investment, and for each contract we estimate the investment return rate. So equality means that all individuals in the system, depending on their choices of the age of retirement and the number of years of contribution, should have the same IRR. So in the literature, we can find different works where the IRR is used to evaluate or to assess the overall generosity of a retirement system and to compare different retirement systems. So here we use the IRR as an indicator of the generosity of the system toward the different scenarios of retirement. So in the Algerian case, for salaried workers that we use here as an example, the retirement age is 60 years for men and 55 for women. The minimum years of contribution is 15 years, and the maximum is 32 years. So for 32 years, we obtain 80% of replacement rate. So that's the equation that we use to estimate the first retirement benefit. So for each year of contribution, we use an annuitization factor of 2.5% that we apply then on the final wage. So and then every year the pension benefits are upgraded by 5% in average to smooth inflation. So here we consider a set of 560 scenarios combining different retirement ages or age of starting work, which can goes from 18 years to 55 years. Then the retirement age can goes from 50 to 70 years, and also 26 scenarios about the number of years of contributions, which goes from 15 to 50 years. So as assumptions, we assume that all workers contribute for retirement. So there is no informal workers, and working career is continuous and is concentrated to the end of the working age. And also we assume that there is no inequalities related to ages in terms of wage. So in order to estimate this, we need a set of information. We need the age time evolution. We need also to have the evolution of contribution rate for retirement. We need also to have the survival function for the global population and also for retirees. There is work of myself and Frédéric Blanchet in 2019 where we estimate the prospective life tables for the Algerian retirees and that we are using in this work. And then we need an estimation about the final wage, the annual revaluation rate of pension benefits. So the objective is to estimate the actuarial lifetime value of contributions and pension benefits. And then we estimate the IRR. The IRR is by definition, is the discount rate, which allows to equalize the actuarial lifetime value of the total contributions against the total pension benefits. So for each of the previously defined scenarios, we estimate the IRR, and we observe here that the IRR vary from a minimum of 9.35% to 13% with an average of 11.5%. And we observe here how the IRR change in function of the first year or the age of start working and the age of retirement. And we observe that those who start working at an early age and then get retired at an early age benefits from the highest return rates, and that's the distribution. So our objective is to make this distribution concentrated toward central value and to reduce the dispersion of the distribution. So our proposition is to start from the actuarial equation between the total contributions and total pension benefits that we see here, and we simplify it. Here, for example, is in function of the final wage, and the remaining part of the first part of this equation is noted as A. And on the second hand, the hand side, we simplify this equation and write it as function of the first pension benefits, and the remaining part of the equation is noted as B. So here we obtain this simplified equation. The first pension benefits is equal to A on B by the final wage. So now our idea is to find a linearized general model to fit this distribution. So we compared two models in addition to the current equation. So currently this equation is employed, and in our proposal aims to write this equation in function only as linear function of n, the number of years of contribution, and in the L2 model we also add the retirement age. So that's the results of the fitting. It is clearly that the model L2 based on both number of years of contribution and the years of or age of retirement fits better the distribution of A on B by N. But compared to the model L0 that we presented previously, there is now big change when we use the model L1. But when we apply the model L2, we observe that all the scenarios of retirement are concentrated in the middle of the distribution. So we moved from almost this distribution to this one. So in order to and that's a comparison of L0, L1, L2, and we observe clearly how our proposal allowed to concentrate the different return rates of the different retirement scenarios into one reduced range. And what remains at this point is to eliminate the extreme scenarios by imposing some constraints about the minimum age of retirement and duration of contribution. So, in first to start, we need to, if we want to make the IRR of all the possible scenarios of working and retirement career, if we want to make them all varying between 11 and 12%, we need to set the minimum years of contribution at 25, and then we need to make the impose some constraint on the retirement age, and to make it between 50, no younger than 55 and no older than 65. So that's the recommendation. And as a conclusion, the classical pay-as-you-go retirement formula can lead to important inequalities regarding individual IRR. In our case, we observed the difference of 3.5% between the highest IRR and the lowest one. So for the long run, it might lead to huge inequalities in terms of wealth accumulation. So it was necessary to reduce this formula. So we have proposed new model allowing to reduce these inequalities and to define the parameters of the retirement equation based on the future improvement of longevity and labor force involvement and affiliation rate to Social Security. So and then we need some regulation to eliminate the extreme values or the extreme scenarios. Also, the proposed model can also be used to define the condition for a targeted level of generosity. If we decide, for example, that the IRR, the average IRR for the system will be 9%, for example, so we can use it as target and define then the equation, the adequate equation, allowing to calculate the first pension benefits from the final wage and the number of years of contribution and the age of retirement. So as a further, this paper was published in 2021. I can provide you with the link later. So as further ways for research, we expect to extend the model to male and female population, because, for instance, it was only applied for the male population, and also consider the case of steady time wage evolution, and also consider the case of wage inequalities and low inflation countries. So thank you very much for attention. This is my email if you have any suggestions or remarks or questions, and you can also scan the QR code to access my website, and you find all the works that we have done on the retirement system in Algeria. And thank you.